channel. We are going to discuss the set theory topics in plus one. We will discuss sets, relations and functions. In the beginning, we start with the set. A set is a well-defined collection of objects. Well-defined means by observing an element or object, we can clearly say whether it belongs to the set or not. Now, for example, the set of multiples of 5 between 1 and 50. The multiples are the set given by A, 5, 10, 15, 20, 25, 30, 35, 40 and 45. Between means 50 is not included. Now, a set is finite if its elements can be counted. You can see here you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is a finite set. A set is null or empty if it has no element. Now, for example, the set of the letters A in require, we observe that there is no A here. So that set is empty. It is null. Infinite set. A set is infinite if it is not empty or finite. So there are three situations. A set is finite, a set is empty, or a set is infinite. Empty set is also finite because it does not contain any element or it contains zero number of elements. We consider more examples. A is a set of 2, 3, 4, 5, 6, 7 and 8. So we see there are 1, 2, 3, 4, 5, 6, 7 elements. So number in A, Na equals 7 is the number of elements in A. Now we take B, 3, 4, 5, 6. You can see B is a subset of A. This B is a subset of A. Reason is every element of B is an element of A. So if every element of B is also in A, we say B is a subset of A. And we say A is a superset of B. So if B is a subset of A, then A is a superset of B. And we denote this as B is contained in A. B is a subset of A, or A contains B. A is a superset of B. Now this is another example. A is 1, 2, 3, 4. B is 4, 1, 3, 2. Now here we observe every element of A is in B. So A is a subset of B. Every element of B is in A. So B is a subset of A. So if these two conditions are satisfied, we say A equals B. So two sets are equal if they have the same elements. No importance for the order. Order can be different, but the same elements should come. Now, in this example is different. A is 1, 2, 3, 4. B is PQRS. We observe that number in A is 4. Number in B is 4. So number in A is, number in B is 4. We say A and B are equivalent. The symbol is A equivalent to B. Here it was A equal to B. Here it is A is equivalent. Same number means equivalent. Same elements means equivalent. Consider topics in set theory. One idea is disjoint sets. A and B are disjoint if there be no common elements in A and B. So disjoint means there is no common element. Now for example, if A is 1, 2, 3, 4, 5, B is 6, 7, 8, 9, there is no common elements in A and B, or we say A and B are disjoint. Now we move to set operations. 1. Union of two sets. As numbers we know there is addition, subtraction, division, multiplication. Likewise in set theory, one operation is union of two sets. Now, union of two sets A and B is a set that contains elements of A or of B or of both. So, union contains all the elements of A or B or both. Now, union of A and B is denoted by A, U, B, capital letter U, B. Now, for example, A is 1, 3, 5, 6, 7, B is 5, 6, 7, 8. Then A union B, now it contains 1, 3, 5, 7, 6, 7. Then we don't repeat. In a set, we represent the element only once. So 5, 6, 7, we don't repeat. 8 comes. So A union B is 1, 3, 5, 6, 7, 8. Now we can see A is a subset of A union B. B is a subset of A union B. And number in A is always less than or equal to number in A union B. Number in B is less than or equal to number in A union B. So this is a fundamental idea. Okay, now we consider A is a set 1, 2, 3, 4. Now 2 is an element of A. We can say 2 is in A. And we denote this as 2 belongs to A. This symbol is belongs to. So 2 belongs to A. 5 is not an element. You can see 5 is not there. So 5 is not an element of A. So these two symbols, this is an element of A, not an element of A. So these two symbols are there. Now 2, intersection of two sets. A and B are two sets. Then the intersection of A and B is a set containing all common elements of A and B. We are looking for the common elements and we take all common elements, and that is denoted as A intersection B. This is a symbol for intersection. Now for example, A is 1, 2, 3, 4, 5. B is 4, 5, 6, 7, 8. A intersection B, common elements. We are looking for the common elements. They are 4 and 5. So A intersection B is the set containing 4 and 5. Example. A is the set 1, 2, 3, 4, 5. B is the set 6, 7, 8. Then A intersection B, there is no common element. So A intersection B is null set 5. Now this is an idea. A intersection B is contained in A. A intersection B is contained in B. A intersection B is contained in A union B. Therefore, number in A intersection B is always less than or equal to number in A. Number in A intersection B is always less than or equal to number in B. And number of A intersection B is always less than or equal to number of A union B. Now here we explain a method of representing a set. Roster method. Roster method means we write down the elements in full. Here we enlist the elements of the set. Now set builder form is another representation. Here we note the property of the elements. Now for example, capital A is a set A, E, I, O, U. You know they are vowels. So we are representing all those vowels there. So that is roster method. Now, but if you say A is the set of X, the symbol is the set of X, such that X is a vowel in English alphabet. X is a vowel in English alphabet means A will come, E will come, I, O and U will come. So we see the set builder form is specifying the property of the elements of the set. Roster form is writing down, enlisting all the elements. So these are the two ways of representing a set. Now we wind up the lesson for the day. We will continue in the next session. For the time being, you go through the topics given in your textbooks also. Corresponding topics will be dealt in the textbook. Go through them. Best of luck for all of you. We will put our efforts together to come up. Thank you.